Oh, oh, I hate to break the. I hate to.
Or might have
I
happened
wish I would have
according
hung
to the
in
scientists in
just a
this
second
paper.
longer.
They believe that in the early universe there were these unusual particles, probably some sort of a fermion particles. Fermions referring to particles that don't really like to be in the same place and tend to repel each other. So for example, electrons, protons, neutrons, they're all fermions. And as these scalar fields in our early universe started to transition, the early fermions very likely could not transition with them. They most likely just started to kind of clump together and create bigger and bigger lumps, with everything around them slowly transitioning into the state where they could not exist. So something similar actually does happen in salt water when you start evaporating it and when the salt starts to deposit on the bottom. And as the scalar field started to transition,
And
the leftover fermions
believe me, if
started
they
to form
they
what
even
the
looked
scientists
at
refer
you
to as
sideways on Paris
fermiballs.
Island, I'd put
And
them
this
on
is an
another
actual
planet,
concept
brother.
that was proposed back in 1994 that some scientists do believe might exist in certain conditions. So in this case, a fermiball is a collection of fermions that should really not be
So
together
at the
because
scientific
of their repulsion force. But in some
collation,
cases, through what's known as the
Nobel
Yukawa
Peace Prize
interaction,
Committee,
they can actually collect
Army
into larger
Board.
pieces. The pieces would be
Wait,
the
go
fermiballs.
back, go back.
And
Wait a
as
minute, I
these
like math.
function, they
Time
can
out. Time out. Hold on. So we got V. Well, let's see if we can find out what V is. All right. In particle physics, Yukawa's whatever, interaction or coupling, named after him, apparently the first man, Adam over here. I know I like to fuck around, have a good time. Is interaction between particles according to the proper potential. Specifically, it is a scalar field. So let's go back. Let's go back to the stone mill in terms of a scalar field. Well, let's just start with scale in general as a field. Do we start with the globe, the flat map? I mean, it works differently. In general relativity, we can make a lot of numbers work just fine on this value. What's the distance between America and Europe? That's fine. It doesn't necessarily need to be on the sphere here to a really precise, accurate measurement. I mean, when we're going to walk it, fly it, we don't know how to fly a plane. We're not going to roughly be there. They already have it timed out. They did the distance once. They did it twice. They did it multiple times. That's what that flight should be. So therefore, that is the scale from ground to takeoff. And if something happens inside of there, it gives me a quantum operator of how to adjust that. Call it in, boys. We got a problem. So we could say, I think that might be the golden ratio. Is that what that is? The capital form of the golden ratio and wave function here. So V, velocity, vector, value is congruent, equal, but not equal to. I think that's congruent. It's been a while since I've seen that symbol. Could be gravity, could be Gresham's law, I don't know, but wave function with a bar over it, I have no clue. Do you? I mean, and nobody does, because why A doesn't. When you go through why there's a high and a low on this, and actually when you look at the periodic table, how about H2O? How about in a scaled matrix where I'm going to explain some of it in a second here. A sum, the environment in which this matrix, this 4x4 perfect square works for bits and bytes. See if I can find a good one. I don't know if you'll be able to see it well, but yeah, there we go. All right, so A1KX. All right, so that's just generally what that is. Now, what am I trying to tell you with that? Well, when you do A equals B, and you would say wave function and wave function with a line over it, unless this is the minus, in which case I would say that then this is that ratio. Basically, we have 6 parts inside here. 1, 2, 3, 4, 5, 6. Can you tell me what the difference in those terms are? How about these ones over here for, I think that is... That's not lambda. That might be gamma. shit. It's been a while since I've seen some of this. That is definitely the irrational number. This is a wave function. I do believe that's the capital form of golden ratio. I know I have it in here somewhere. I actually use it for the start of Schrodinger's equation here. And then it might be photon too, but I'm not sure. It might be another way of describing the photon in Greek. But that might not be right. It's been a long time. I know that's the capital form of it over there. But anyways, we're going to get into breaking down Schrodinger's equation inside of here. HT, wave function, dimensional axis, IH. I actually did a little differently inside of here. You find multiple forms of Schrodinger's equation, which for them, they might have been talking about trigonometry, algebra from that point in time. As you actually go to nut and bolt a mathematic review, and let's say instead of all the fluff that goes in, I just want the diamonds. Just show me the values of different ways this equation is positioned. I might have a to the power of it on there. That's a value that represents a certain field. And so, well, just to get back into it, we're clumping all those Fermi. Is it Fermi paradox we're dealing with? Yeah, Fermi balls and paradoxes inside here that says that ball. Be twistor theory ball. Yeah, just because I like Benzro popping up on you inside here. Has an axiom to it. If I, firstly, relative. It's going to be, am I moving forward in time? Are we talking about a review back in time? Are we talking about, I don't have the review from back in time now, so I have to go back in time? There's a lot of Euler's numbers to the way that V could equal a specific term. When those things equal out to the stone mill, 1, 2, 3, 4, 5, a fifth dimensional object on that. It's a planet, it's a country, it's a state, it's a building that has a specific tread cut in it, or a specific guy. You could get fifth dimensionals. If I want to say the globe or the universe, what am I in a seventh dimensional object now? And I'm factoring Hawkins radiation from here, light from the opposite side of the black hole. How about that saw? A glint that's emitted. How about a symbol that represents that? Well, at time space, it would have been Larry. You know what I'm talking about, Larry. I'm tired of it, Larry. I don't know a Larry. But if I did know that, Larry, you know who you are. Go on, Anton.
And actually collect into larger pieces. The pieces would be the Fermi balls. And as these Fermi balls grow larger and larger, at some point they can reach a threshold.
See, what's cool about this, one of the differences, Anton does this cheap and dirty. He does it as a review of mathematicians that
and as a result,
grabs clip arts, has a system, and presents it very well towards the informational standards. You don't need astrophysics to go ABC with a project in the stone mill, do you? How about if we take that out there to narrow it down to just the heat vex sensor breakdowns over time, or blade rotations that pop up. This is just cosmic radiation background on blast. We're cutting it down in the quadrants of the chessboard there, or the town. Let's say on my scale Hancock there, I wanted to change that over to Binghamton. Would it be congruent for me to...
Depends on
would it be
first is the
congruent for Hancock? I can do it on a scale of about a mile.
For sure. But the
you know, that's all right. But what about Binghamton, where I'm going to have to, in its entirety,
in the early universe, some other types of fermions
be able to take that
today,
from Hancock,
and that's something
its entirety. This right here is probably a scale of, which is at 5,
now,
10,
the only way for us to
about 10 miles. Well, let's look about the size of a city.
Try to recreate this early
so inside of there,
but
I could have blown that up to blast on here to
This
bend
would
the same
require,
size.
way more energy than we can actually produce right now.
Way
And so
more
for now,
energy.
this is
And like I
just a
said,
theoretical
at the
explanation.
global economic
The only other
cost,
way to
the
try to
United
prove this
States
is to
economics
maybe
cost,
find one of these
that's one
primordial
number.
black holes.
Without the
So in this
individual
case, the scientists
American
do actually
tax
make a
bracket or
speculation about
China's or
the
Russia's,
mass and potential
individually,
size of these
how
black
could you
holes.
ever get the
There are
global?
calculations
Let's shrink
suggest
that down.
the mass
How
of a
do you
typical
get that
primordial black
without
hole
a single
would be
product
about 10
being
to the
sold?
power of 14
Or
kilograms,
troop doing a specific
equivalent to
action?
the total mass of carbon fixed by
Corn
photosynthesis
to
on Earth
soldier,
every
corn
single
to
year.
carpenter,
Or
corn
approximately
to
10
you
times
running
the mass
bare
of the
ass through
famous
a cornfield
67P
backwards.
Churyumov-Gerasimenko
Oh, yeah.
comet, which would be equivalent to a mass of an asteroid that's
Well,
approximately
Anton does a
3
better job of
kilometers in
presenting
diameter.
it.
But I guess
So I
the
mean,
question
first when it
is,
comes to
well,
Burke and
can
Jarrett's
these
conjecture,
black
which
holes
one's
exist?
worth more?
Remember,
Does it
black
have a
holes
higher
also
value
lack
to
range.
you than
That's, of course,
listening
based on
to
the Stephen
some
Hawking's
dry
prediction of what we
astrophysicist from
refer to
NASA
as
talking to
Hawking
you?
radiation. And black holes that are not very massive
Well, I'll give it
are
to
going
Anton.
disappear pretty quickly.
Which
And so
name
I
do
guess
you
the
know
question
more?
is, how long can a black hole of this mass exist?
Seems
in the
like he's
universe?
done the same
And there's
research
actually a really easy
every
way to
day.
calculate this. There
You
are a
know,
lot of different
they'll
calculators
take it
online,
for
but I found
weeks,
this one by
months,
Victor Talk to be
years,
one
some
of
of
the
these
most accurate
experiments.
ones.
Now, I understand the
And
data
if you
compression
enter the mass
equals
of the
that.
black
You want to
hole,
be
it tells you
careful.
pretty much everything about
Who
it,
about
including the potential lifetime.
time equal, or
And so if
temperature,
you enter
excuse
the
me.
mass that's proposed
T
in the
equals
paper,
temperature now,
we
too.
discovered that this particular black hole can actually
What's the
survive
difference?
for a pretty long time. That's approximately 100
You don't have a
million
matrix
times
that
longer
does that
than
on a
the
right-hand
current
rule.
age of the universe.
T is
And
always
so
time
these black
first.
holes
Why?
are
Because I
going to be
told you.
around
You
for
don't
a
do
long,
anything
long
different.
time,
You got to use a
assuming they
different symbol.
exist.
Time with a
Now,
degree
can we
over
find
it.
out if they exist?
Without
That's
that
the other
symbol,
question.
to that
Currently, there's
platform,
really
to
no
that
way for us to
square,
determine
that
if they are
extra
real
step, bits and
and if
bytes,
they actually are
the
out
time
there.
is in
But some of the future
space-time
telescopes will
for
definitely
the
allow us
distance
to
or
study
action
what's known as
behind
the
it.
microlensing
Light
effect.
behind it that
In
gives
this
me a
case,
specific
extremely
value. This
fast
value
microlensing
could be
effects.
temperature, could
The
be
effects
money,
produced
could
by
be
these
could be a
very small
time
bodies,
where a
extremely dense
specific
bodies,
value.
passing in front of
Penzrell's
distant
all
stars.
about go
And if
through
by
the
some
black
chance we
hole,
start detecting a lot of
and
these microlensing
time
effects
turns
all over
into
the place,
space, matter
especially
turns
from objects that
into,
seem to
well,
be asteroids,
matter turns
but
into
are not really visible in any
space,
other way.
right?
In that
Because we're
particular
talking
case,
about
there might be a
assembly
chance to
processes.
discover some of these
How big is the
primordial black
area
holes.
that I need
Although
to
at the
do one
moment,
hillbilly
it's still
spinner?
really far
How
to
about
tell
the
if we'll ever
area
be
to
able
do
find them.
hillbilly
But since
spinners
they
to
represent
Sal's to
approximately
Gander Mountain, its little
80%
fishing
of
rig
all
that I
the
come
mass
up
in the
with?
universe, well, they should
Well,
be
if they
pretty
have an
much
order
everywhere
and I'm
around us,
getting
and we should
cases
be
of
able
them
to
a
find
day,
possibly even
I'm
in
going to
our
need a
solar
bigger
system.
area than
And
just
so in
me
that
cranking
sense,
out that
this
with a
is
box
actually
over
something
here,
really
take the
exciting.
box out on those
If one
time
day we start
scales,
discovering
those
unusual
forms of
emissions
those
different
forms
X-rays and
of the
possibly
matter
gamma
in
rays
that
coming from
Bernoulli's
some sort of a
equation.
not so distant
Now, it
object
gets a
in
little
the
bit more
solar system.
comprehensive
In that case,
when you get
that would
into
definitely
physical
be
matter,
some sort of a
but we
primordial
already
black
have a
hole.
lot of this
But since it
collision
would
where
be
we can
extremely
go
small in
to,
size,
you know,
chances
calcium
are
and
this
or
particular
calcium
black
and
hole would not
plutonium
really
collisions
produce
that
much
make
radiation
fluvium.
and would still
We
be
know
somewhat
that result.
invisible. These objects
That's
would be
what it'll do.
1,000
Now,
or several
it's not
thousand
T,
times
it's
more
not this,
than a
it's
typical virus.
orientations of a
And that means that it
physical
would
time
still be
space that
extremely
is
challenging
ITER,
to
that
find
is
them
CERN.
and to actually prove their existence. Nevertheless, it's still an interesting
We
theory,
did.
an interesting
But
proposition,
black holes
and
always
a
do it.
theory that's been
Stars,
proposed many times with
supernova
different
collisions,
explanations
those are the
before.
kinds of
So it's not something
spaces
that
where that
scientists
needs to
do
be.
not
It just
think
can't be in the
exists. As a matter of
Boyde's
fact,
void.
primordial black holes are an explanation for a lot of different
Passing
phenomena,
through at that point
including
in time. There's
supermassive
nothing
black
really to
holes.
decay it.
And so their
Space isn't
existence
empty,
is almost certain. How
but
small they
it's
get and
massive.
also their numbers
And at
is,
that
of course, a
level of
completely different
mass
question.
and
Something that we
expansion
cannot
and things
currently
racing
answer.
around everywhere.
Anyway, on that note, well, that's all I wanted to mention. Check
Well,
out the paper
I don't
in
want to
the
undercut
description
from
below.
Anton
All the
here.
other
I want to
relevant links
specify
below.
what he's doing
Subscribe
is
if you
trying to
still
give
haven't.
you a
Share
bit
this
of
with
gravity to
someone
work
who
with,
loves
something to
sciences,
have
and maybe come
conversations
back
with
on
at the
board
water
with us.
cooler and
Maybe support this channel on Patreon.
make collisions
Or join the
with,
channel
and therefore
membership,
you
or by
can
buying the link
harness
in
that
the
energy.
you can
He's
find in the
one
description.
person here. He
Stay
puts
on
out a
the
lot of
follow,
that
see
for
you
you
tomorrow.
for a
As always,
like
bye-bye.
out here, and maybe you buy some of his merch, right? Catch you on the next one.